Hi everyone, my name is Bikalpa Neupane, and I'm currently based out of Boston in the United States. Prior to that, I was at Penn State finishing my PhD in human AI interaction, particularly applying my HCI methodologies to issues of artificial intelligence. And I'll be talking a whole lot about that as well. And I know it's pretty early in the morning, so thank you all for coming in here. And it's nice to meet you all virtually. So before I start with the topic, let me give you a brief introduction of who I am and what I do today. I'm from Nepal. I attended Brigham University of Utah for my undergraduate degree. And then I moved to Microsoft to work as an engineer for a couple of years, and where I decided to join Overstock.com. It's an e-commerce company as a software manager. At that point, it's precisely when I joined Penn State for my PhD in human AI interaction. During my tenure at Penn State as a PhD student, I also got an opportunity to go and visit EPFL Chile Lab, Computer Human Interaction Lab for learning purpose. And then I got an Australian Endeavour Fellowship to work on educational data mining and text mining in Connected Intelligence Center in Sydney, Australia with UTS. And then I have been involved with the United Nations and World Bank because I am a technologist who truly believe the social impact that technology could create in our environment, in our society today. And today I am with the Natural Language Processing Group at IBM Watson. IBM Watson is the AI at a very large umbrella term, AI for IBM. And I do work at multiple levels as in engineering and research and in product capacity. And in Nepal, as in my introduction, I also lead an organization, not-for-profit research organization called Human Computer Interaction Institute of Nepal. Most of the founders and co-founders are in the United States, but we have a smaller group that tries to do some work with some research importance. What I'm really trying to do with the HCI in Nepal is kind of introduce HCI in Nepal because, during my last interaction in Nepal, whenever I go and talk to someone about HCI, everyone thinks it's design, everyone thinks graphic design and UX design. While that is partly true, I also wanted to make sure that people know what HCI really is and what is the direct impact that we could have, we could use HCI and AI and produce some work of some greater research importance. So that is my goal over HCI. And I'm also the founder of this an egg-tech stealth, very small or tiny startup called OmVisor. I won't be able to talk a lot about this here, but if you guys want to learn about this, OmVisor.com Facebook group that has a lot of stuff about what you need. So today I'm going to be talking about in general a mix of everything, right? And natural language processing, which is my current team at IBM Watson. I'll also be talking about the human components of AI a little bit as a part of my fairness and bias talk in the later half of the presentation. So natural language processing. Before I go and define what natural language processing is, most of you guys are already familiar with this. I was just looking at, because I work at IBM and I'm humbly bragging my opportunity here to see where IBM lies in NLP space today, right? In terms of different attributes that we are looking at. And then there's in terms of machine learning and NLP publications, academic publications, research papers, and scientific breakthrough. We stand right at one of the leading NLP providers in the United States, if not the entire world, working on machine learning and AI. That's where we stand. We compete very strongly with leading organizations, elite institutions, Stanford, Carnegie Mellon, and institutions like that. So this is less of a business stuff. So what is natural language processing? Natural language, in a very high level term, is an AI that speaks the language of your business. That's all about it, right? Because The problem that we are dealing today is essentially a large amount of structured and unstructured text. And being able to ask or answer any kind of semantic questions, it's challenging. Whether you look at legal documents, financial documents, medical, or any type of text that you want to be searched for or queried after, you would want some kind of NLP engine behind this thing. Think about how many decisions you are making today, right? So we got so much emails, for example, NTC and NCL call center, they must be getting millions of phone calls a year, right? Millions of customer requests a year. So is it humanly possible to look at all that calls and the emails and then act upon them in a quick time frame, right? And that's theoretically very impossible for a limited human to do it. So we need to understand those kind of data. We need to understand what our customers are trying to do. We need to understand what our customers are saying to us. So that's where we use the NLP, right? Using the language component of the human and applying to the technology. And as you guys already know this, right? Language is very hard. It's very ambiguous. Things that you say in Nepal does not mean the same in the United States. Other than the language differences itself, right? English versus Nepali versus Swedish versus Korean, the meanings may change drastically. Even within the United States, people use slang very differently, right? When someone say, "Oh my gosh," right? How would you say if this is a positive thing or a negative thing? Or is it a surprise versus a disappointment, right? Just the nature of the language makes the natural language processing very interesting and very difficult to handle as well. Now, if you look at where the AI technologies are going next, Gartner is a leading analytics company. They do a bunch of surveys and reports, looks at industry reports, enterprise benchmarkings, and produce different kind of metrics for industries to look at and decide how they are doing in terms of the competition, in terms of the market value. I was looking at some of the numbers from the Gartner report and then found out what are some of the things that is going to exist or going to be developed in the next 3 to 5 years, 10 years down the road. Some of the things that really stood out to me, emotion AI, right? They are at the peak of the innovation triggers, text summarization and natural language generation, basically an overarching term for natural language processing at a very high level. And there are things at the trough where there's basically settling down is chatbots and conversational AI, right? So this graph is here to show you where we stand in terms of AI and NLP toolkits today, from the very official trusted source. And a lot of what I just talked about ties into the simple thing that NLP is no longer an experimental field of AI. It started back as a part of a Turing test in 1950. And when IBM and Georgetown University built their first, automation translation, we call it first NLP, and coming to the world where we are today, where we are dealing with Alexa, right? Cortana, Siri, all that voice-based assistant NLP, that's where NLP lies. It is no longer an experimental field of AI, rather a production system, right? That's already been deployed by organizations at a much larger scale. In terms of the technicality of the approaches to NLP, we have different systems. Rule-based NLP, which basically is provide a set of heuristic rules, ask computers to do a certain set of tasks. So you provide the rules, just like SQL, right? So if you are a database guy, you would just provide a SQL statement. You'll just provide a specific filter and specific rules. You can use that as a part of the simplistic NLP engine, right? And I'm sure you guys have done it or used in different fashion. And then you have a classical machine learning statistical model, which basically means you use a bunch of different machine learning algorithms and you use that to learn from the data, do labeling, annotation, of whatever you need to produce the NLP output that you want. And there's neural network based NLP, which is rather growing. I haven't really seen this adopted at a scale in industries, even in the United States. So it still is it's a work in progress to scaffold neural networks as a part of the NLP engine. And some of the, I know we lost some time, so I'm going to go really fast in some of these slides. Some of the popular NLP and NLU text analytic features that you are looking at, entity recognition, right? Given a set of text, you will be able to find out which of these terms are the name of person, or the name of organizations, or the name of place, name of food, right? You call it entities, right? So your goal is to find those entities from the set of the text that you are provided. And as a customer, right, or as a developer, you tend to apply a lot of this, cognitive computing features to your use cases. So, for example, if you are given a car, let's say if you're given a Honda car, you will be, looking at how do I categorize this Honda car? What is this, right? You will say it's a vehicle, it's a Honda, and it's a car, and you will go, further down into and then look at, okay, it's more of a certain type of car and not the car that you're looking up for or not. And then you can also look at concepts, right? So for example, given a large summary of the text, if I have to provide you a document and the NLP is capable to quickly read through or scan through the parts of the document and summarize you something, we call it summarization features. Or if you want to look at the concepts from that document, the concepts model will give you the overall concept associated with that article, right? So that's one of the NLP features. The other one we call is emotions or tone detection. For example, if I'm talking very loudly, if I'm talking with an angry face, very loud tone, NLP can tell me, or NLP can tell the call center saying that this customer is rather unhappy, is frustrated, disappointed, very angry, right? So just by hearing what the customers say, your tone, your audio, or even from the speech to the text, with NLP, you are able to find out things like emotion in your sentence, your tone in your behavior, right, in your speech, or sentiment analysis, looking at what is the sentiment of the particular text or the particular audio, right? All sorts of things that you are able to find and do through the NLP. And these are some of the common NLP use cases that the current production system supports across the industry. Document classification, right? There's thousands and thousands, like millions and billions of documents in a library. How can you look at all those documents based on a certain parameters and classify them, right? We call it classification systems. And then there are chatbots, right? And question and answering systems, virtual, digital assistants. Everything as the backend has some kind of NLP capabilities infused in it in different ways. I'm going to quickly skip this. Just as a FYI, I tried to design this slide for someone as a mixed audience, someone who has a business interest and someone has a tech interest as well. So if you're one of those, business-oriented tech person, this is where NLP is growing in the next few years, right? By the industry. BFSI is called banking, financial, and insurance industries. So the next thing to look at is emotion AI, text summarization, natural language generations, right? And I'm also giving you some dollar value directed, I grabbed it from one of these, analyst report, probably Gartner Forrester report. Cool. So that's a little bit of NLP. I didn't want to go through the more of the technicality here. And if you guys have more questions around implementation of classification systems, or emotion systems, tone, sentiment analysis, I do a lot of that work at IBM Watson, and I also do more of the practical and programming centric exercise for a lot of this course, in my Harvard extension course and the other business schools that I teach. So if you guys have any questions in terms of real programming and assignment and implementation, do let me know, and I can probably help you out there as well. So next, I want to quickly jump into the topic fairness and bias. And I want to give a shout out to my friend and my collaborator, Dr. Sayam Golhotra. He's currently at India. I invited him to do a quick show of his slides, but he couldn't make it. Fairness and bias is one of the things that Sayam and I have been working on as a part of our PhD dissertation as well. Sayam did a really good job producing a software called Themis, which is one of the first in the United States as part of the academic literature. We call it Themis testing software, basically applying his software to test whether some NLP or machine learning is fair or not. He couldn't make it here today, but he's in India having fun with his family. He's currently a postdoc at the University of Chicago, competing innovation fellow, but I'm going to speak some of our collaborative work. This is very important, right? I know, let me tell you my journey, right? I started as an engineer, and most of my time was spent in just designing systems and just coding, from day to night. That is all computer science and engineering to me. But when I joined my PhD program, I was very fortunate to work with one of the founders of the field, human-computer interaction. My advisor, at that time, Dr. John Carroll, he founded the field human-computer interaction when he was at Virginia Tech and moved to Penn State. And then he instilled in me the idea of the importance of humans in the AI process, right? A lot of the discussions today, when you talk to someone else, it's centered around the concepts of accuracy. Well, what is the accuracy of the model? 70%, 90%, 95%, right? That's one metric people look at. The other metric people look at is the p-value, right? Is it significant or not? That's another metric. And other performance metrics, right? You look at runtime, memory, and things like that as well. But those metrics are not enough, right? We are deploying these technologies to solve some of the critical human problems today. And as a human, as a software developers, as a computer scientist, AI scientists, we need to vouch for the role of humans. That's where the concepts of human in the loop come in, right? I'm not here doing the design work for AI. As a HCI researcher, I come in and say the role and try to insert the role of humans in different phases of a machine learning lifecycle, whether it be leveling up the data set or annotation, or in the input stage of the data set, or coming up with the fairness metrics, benchmarking, or system testing, right? You can insert humans at any point. And this is a really good quote from ICLR 2020, one of the talks that I attended, really vouching for the marginalized and underrepresented people and the role that they need to have in the AI lifecycle. Going back to the story I was telling about my PhD journey, I have completely transformed from a systemic thinking, an engineer, hardcore programmer, and a system engineer to someone who likes to call myself an information scientist and vouching for the role of humans in computing systems. It is very critical, right? So I try to label myself more as a socio-technical researcher now than as a pure computer scientist, and only because of the roots and philosophies that I've borrowed from human-centered design, HCI. Let me talk a little bit about my PhD dissertation and how that relates with the fairness. In my PhD, I investigated the role of AI and machine learning in hiring, right? I'm not super familiar with how hiring takes place in Nepal, but in the United States, let's say for a particular role, there are 100,000 applicants applying for one or a few roles, right? And because these industries, these companies do not have the human bandwidth to go through each of these CVs, resume by themselves, they try to use AI and machine learning to kind of classify people, right? So for example, Bikalpa is not really good fit for this job, he's out. And person X is really great, he's in. So these companies have been adopting third-party AI and machine learning tools to look for the right candidate for the job, right? So basically, this is the step that people use in hiring in the United States. And with my PhD, I try to answer questions like, are these AI and machine learning softwares and algorithms that are looking at someone's resume and making our decisions, are they fair enough? Are they penalizing for someone who they should not have penalized for, right? So that is the overall, theme of my PhD dissertation. And there is this company called HireVue, which was an inspiration for my own PhD dissertation, right? This software tool is used by many companies like Nike, education company, IBM at some point in the past, and different governments. What they do is, instead of sifting through thousands and thousands of resumes by human, they do it the automated way. Basically, the algorithm does it for them, right? So when you are interviewing for a job, they send you a link. You then open that link and start recording yourself. Like you are talking to a computer alone, right? As if the other person is there, but in reality, there is not. And let's say in the tool, there are 4 questions that you needed to answer. And some of these responses require you to record a video. And the candidates are not directly talking to a manager, but they are sending that pre-recorded interviews to the company, right? Now, what is happening behind the scene is, well, what we hypothesize, we don't know what's happening behind the scene because the code is not public, open source. According to the company, the HireVue as a company, they say that the responses to these video interviews, they contain, full data such as the content of the verbal response, intonation, nonverbal communications, whether I am brown versus black, right? Whether I have accent, my human behaviors, expression, a lot of psycho-linguistic attributes. They're looking at the machine learning classifiers. And that to me doesn't really sound fair. So I started investigating softwares like this, and because I couldn't have access to their source code, I started designing and developing my own machine learning classifier, conducted a series of experiments, and really tested for the fairness in these kind of things, right? So that is the overall gist of how AI systems could be fair or unfair to a particular candidate. Now, if you look at this slide, we call it machine bias. And this was published in ProPublica 2016. There was a popular software called Compass, which was used by judges in Florida, right? A Supreme Court or some kind of court systems. What was observed in that software was this particular software was biased against the black defendants, black criminals, than the white defendants / white criminals, right? And then as a part of their testing, when they flip the gender, and the output of the software changed for 45% of the individuals. That's scary, right? So when you just have data and you blindly turn that data into a model, wrap that model into your script, into your software, and then people buy and use them, there's a consequence that lies in it. Someone who should not be penalized is being penalized and spending years and years in the prison, right? This is the very dark situations of the AI being scary side. And there are many stories out there in literature, right? So you find out and read some of those. And there is a facial recognition, which we all think is pretty cool, right? When someone is monitoring your face, it seems like too cool when you have something on your device. But these algorithms, like facial recognition algorithms, have been found to be highly accurate for males and inaccurate for females. Again, based on one or a few studies. And due to this, you probably know there's a backlash for computer vision and facial recognition algorithms as well, right? The Google, I think it was Google, right? Google's algorithm pointed out 2 black people as chimpanzees, rather than humans. Their facial recognition algorithms failed completely, for the time being. I'm sure they have fixed it by now, but that's an issue. Now look at this. Language translation directly from Google and Microsoft Bing. I provided a statement. He is a nurse, she is a doctor, right? I said he is a nurse, a male is a nurse here, and she is a doctor. And then what I did was I looked at two gender neutral languages, completely gender agnostic, Hungarian and Turkish, right? I wanted to translate English, help it auto-detect, and try to see what happens if it goes to the Hungarian and Turkish language. And as you can see, the gender of the nurse flipped from he to she, and the doctor flipped from she to he, right? If you look at the screen properly, where it detected English and going to Hungarian and the Turkish. So basically, they are classifying things because our data in the past suggests that women can only be a nurse and men can be a doctors, right? So issues like this is pretty creepy and pretty scary, right? This is just one example. Now, why did the biases occur? Where does it occur, right? There are different stages of bias and there are different stages of fairness. There are multiple 40, 50 different definitions of this, and I'm not going to go through all of that in the interest of time. But in general, the common problem is the input data, right? Whenever you try to feed in systems with whatever data you got in the system, when there's a bias in, you get the bias out, right? As simple as that. And then, there is another application of AI where we found the introduction of biases, for example, loan prediction. In the US, when you try to apply loan for a house or a car purchase, they are probably looking at things like age, sex, race, income, your address, your credit score, right? Your history record, basically. And you go to the bank, and the bank will say yes or no to your loan application, depending on what the software tells you to do. And historically, they have been adopting different tools, and most of those tools came out to be pretty biased. Boom. And they never investigated why there was bias. The machine learning and AI started, they remained black box as a whole. So what we're talking today is a different kind of biases. And there are, like I said, there are different kind of biases. There are different definitions of fairness. I'm not going to go with all of, about all of them. So one of them is a systemic bias, and that this is the most common reason for biases in the classifying systems today, because some of these classifiers are trained on the data where, in the case of previous examples, females were denied loans historically, right? Females meant nurse and male meant doctors. That's it, right? So we rely on a lot of historical data that is already biased to some degree. In fact, to a whole lot degree, right? Things that happened in our society as a part of natural progression, dating back 2 decades, 3 decades, or even 100 years ago, we have been accumulating data that is not a real representation of what and where we are today. Now, suppose we control for systemic bias in data, and let's say we clean such data, we clean every mistakes, and there is no systemic bias, right? But there could still be, the final prediction could still be unfair because of different problems we call it lack of representation or selection bias. So basically, when you are training a machine learning classifier on the data set is the sample of the real world out there. And if you cannot contain that sample representatively and accurately, it may lead to some kind of bias. You can see on this slide here, there's an audience with old people and the younger people. And I happen to pick only a subset of those people and completely missed out on the old people. Look at that. There's only 3 people on my representation set. I am missing on the old individuals. That's a flaw. Even though we are looking at the real world problem, we are not encapsulating them in the right way and in the right manner. Let's say, suppose we fix this in the data. even then the classifier could not be fair. We talked about systemic bias, we talked about representative bias, selection bias, but there are also bias which is hidden. For example, in the loan prediction system software, if you hide the sensitive attributes, right? So personally identifiable information, we call it PII, like sex and race, you could still find out those details by looking at other attributes like address. For example, I could tell you could hide someone's age and income and race, someone living in, let's say, New Road, Kathmandu, but I could still tell the purchasing power of people in Kathmandu or the New Road without you telling me what is the age or sex or the income level of those participants. Because to me, by looking at aggregated data like address, there's an assumption if someone can afford to live in New Road, Kathmandu, someone is pretty wealthy enough compared to someone living in the far western region of Nepal, right? So that's just a very simplistic example. But my point is, even though you try to take care of a lot of these attributes by yourself, there's always bias hidden. There's always ways to go and find out a whole lot of details, hidden details. And that's where you need to be very careful in, and that the system still becomes unfair. One example about Amazon. Amazon does a pretty good job about same day delivery. You go and order something on the Amazon today in the United States, it could probably give you the stuff the same day or maybe the next 2 days. When they were rolling out these features like a few years ago, they completely missed out on the neighborhood that have low income levels and the neighborhood that have high amount of marginalized, underprivileged, and historically Black populations. They didn't mean to do that, but they did. If we look at the Boston, Roxbury side was completely avoided was not afforded the Amazon same-day delivery option. On the Chicago, the South side didn't have that option. And Atlanta, the South Atlanta didn't have the same-day feature. And Amazon was relying on the machine learning model to help them make such decisions. And they were discriminating people based on the attributes like address codes and income level, like postal codes, things like this. So today, if you're looking at the biases, there's different kinds of biases that we talked about, right? And there are different ways to deal with it, at different stages of the life cycle, machine learning life cycle. Whether you specify a requirement, fairness requirements upfront, working with your business stakeholders or policy stakeholders, and the data collection, preparation, training, and testing phase. All of this phase would require a lot of the ways to deal with the biases. Again, I know I went really fast. So if we have time, I'm open to questions. I know we probably have a few minutes. Again, you can reach out to me. My email address is there for any questions. And yeah, I'm done. Thank you so much, guys. Cool. I didn't see any chat or any questions here, but feel free to reach out to me if you have any questions around AI bias and fairness. That's my pet field that I've been working on it for quite some time now, AI fairness and bias, including natural language processing models. That being said, yeah, I'm done. Thank you so much for everyone for listening, and keep in touch. Thank you.
All right. Thank you, Dr. Neupane. Hopefully, we can have few questions. I know we're a bit tight on time, but do you have questions either in the chat or mic? Do we?
Yep, I can answer if there's any question.
All right. Uh,
Hello.
Yeah, probably. Yeah, sure.
So I have a question regarding biasness. So you talked about, biasness in data is really harmful, but are there some kind of biases which you really need and you don't want to remove them from the data set? I mean, I want to ask, are all biases harmful?
That's a really good question, and something that requires a very long discussion. But that's a really good question. I like it. So sometimes the systems are not biased as themselves, right? So as a developer, you try to train a machine learning classifier, and sometimes there's a conscious bias and unconscious bias that may just creep in into your machine learning model. That's number one. Number two, if you look at the human psychology, we probably have more than 180 human biases in some ways or another ways, right? That we have inherited from the past, from our society, from our generations. So when you try to deal, I wouldn't label any biases as good. I'm pretty careful on how I term that, but there are ways where you could sometimes induce bias to control for the data parameter, right? To control for the weightage in your machine learning model. For example, if you know that a model is biased against Black population, or let's say women, you could, and you know the context and the rationale behind why that is biased, we tend to overweight the sample of those people that are, of those data sample that are less represented, right? So what we're trying to do is we're trying to induce bias in some positive reward, in positive ways. That's one of the example. We call it, there are different techniques. We call it gender balance, parity balance. We also call it anti-seed phrases. For example, I can tell you my real example. In one of the software that I had been using for the past few months, labeled someone as racist, right? So when someone said, I hate a system, like I hate ice cream, and the model categorized that sentence as Islamic, right? And that's a pretty racist model. So what we did was, even though that is unintentional bias, we went to the system, we tried to insert anti-seed phrases that counteract for the negativity in those terms, and then use a bunch of algorithms to kind of satisfy and fix that. So I would say, I don't think I'm competent enough to tell if a bias is good at this point. There might be researchers working in different universities, whether that biases are good or bad, but there are ways that sometimes we try to intentionally add bias just to make sure the system is not deterministic in one way or another way. Yeah, and if you want to learn more about this is a really good question. Yeah, send me an email. I could also probably point you to a bunch of literatures out there.
Yeah, we have one more question on Zoom. Bikalpa, you want to?
Sure. The question here is how rigorously you tested the machine learning system on the daily basis from the perspective of bias and fairness. What is your go-to tools framework to detect and resolve bias and fairness issue from the engineering perspective? That's great. Let me see, I can quickly show you something. So in terms of the real engineering workplace, right? For example, I'm just gonna show you one slide really quick, and probably this will help. Right. So this is we call a feature called explainability at IBM. This is, and if you go to the IBM natural language processing models, we try to provide our customers, those who borrow our data science model and classifiers, we try to provide them also peace of mind, right? Making sure that they know they're not just playing with a black box, but something that's explainable and interpretable, machine learning. We introduce a feature called explainability, which is just a Boolean flag. You can just go to your code and change the Boolean flag from false to true. So what that does, is basically it figures out what part of a document are highly likely to be the document representation, and from those set of documents determine which of those are likely to be the best result and which of those are not likely to be the best result. And the reason I'm showing you this is IBM is probably one of the first leaders out there in the industry today to introduce the concept of AI 360 toolkit. You ask for the tools, you can go and look it up. It's called AI 360 toolkit or AI fairness toolkit. It's out there in academic literature and also in the industry. But from my experience, if you go and talk to other industries in general, I haven't seen that many fairness standards are adopted. And I'm working with my collaborator like Siam and we have been thinking about how do we take some of these fundamental machine learning in technologies, explainability concept, fairness concept, and try to use that to gauge the fairness and bias in the different tools. So to answer your question, take a look at this tool called AI Fairness 360 Toolkits. It's widely popular. Number two, the adoption wise in the industry, unfortunately, it's very little, and we don't have that today.